So the goal for today is to figure out what more rules can I conclude from the Pythagorean theorem of trigonometry, and we'll have time for 2 proofs today. So this is just what else can I expand upon my toolbox so I'm an unstoppable force. I can use the Pythagorean theorem of trigonometry to do harder proofs. Kind of like your RPG character in a video game. You start out with a limited variety of tools and weapons, and as the harder levels come, well, now your weapons and your toolbox and your skills and abilities, you're gonna be stronger than ever to do the harder stuff. So first things first, just play around with it. Just follow my lead. So all of them say sine squared of theta plus cosine squared of theta is equal to 1. Well, let's say I subtract cosine squared of theta from both sides. So let's say I want to isolate sine squared of theta. So now I figured out that sine squared of theta is equal to 1 minus cosine squared of theta. And just like that, I've got a new rule that if we have sine squared of theta, well, that's equal to 1 minus cosine squared of theta. Well, let's try the other way. Let's say I go back to sine squared of theta plus cosine squared of theta, and how do I get cosine squared of theta isolated now? All right, let's say I subtract sine squared of theta from both sides. Now, sine squared of theta gets canceled out, leaving me with cosine squared of theta is equal to 1 minus sine squared of theta. And now, cosine squared of theta isolated is 1 minus sine squared of theta. And just like that, I've got 2 new rules in my toolbox that are going to help me out big time. Okay, well, that's all fun. But now, just play along with me. What happens if I were to divide both sides of the equation by, let's go with sine squared of theta in the first example. So remember the distributive property? Well, if I distribute multiplication over addition, well, why can't I distribute division over addition? Because this is no different than multiplying both sides of the equation by 1 over sine squared of theta. So now I've got sine squared of theta over sine squared of theta plus cosine squared of theta over sine squared of theta equals 1 over sine squared of theta. Now, use the rules that were given to you. We're just going to apply the square to them. So all I know are the Pythagorean theorem of trigonometry, but I'm also going to still use these trig ratios. So sine squared of theta over sine squared of theta, well, it's the number divided by itself, so that's a 1. Okay, let's see. Cosine squared of theta over sine squared of theta. Well, I remember distinctly what cosine over sine is. Anything look like cosine over sine here? Ah, right there. Cosine over sine is cotangent. That's going to come in handy. So if cosine over sine is cotangent, then cosine squared over sine squared is cotangent squared of theta. And 1 over sine squared. Well, I don't have a rule for 1 over sine squared, but I do have a rule for 1 over sine. Ah, there it is. 1 over sine is cosecant of theta. So therefore, 1 over sine squared is cosecant squared of theta. And just like that, I got another new rule in my toolbox. So cosecant squared of theta is equal to 1 plus cotangent squared of theta. Very nice. And just like that, I've got 3 new rules in my toolbox. So remember, I divided both sides of the equation by sine squared of theta. So let's go back to sine squared plus cosine squared. So if I divided by sine squared of theta on both sides, why not? Let's see what happens if I were to divide both sides of the equation by cosine squared of theta. Once again, if I were to divide addition by one term, then each of the terms gets that divisor. So now I've got sine squared of theta over cosine squared of theta plus cosine squared of theta over cosine squared of theta is equal to 1 over cosine squared of theta. Okay, now let's analyze this piece by piece. I don't know sine squared over cosine squared, but you know what I do have? I do have sine over cosine as one of my rules. Ah, there we go. Sine of theta over cosine of theta is equal to tangent of theta. So therefore, sine squared over cosine squared is tangent squared of theta. And since we've got cosine squared over cosine squared, that is 1. And 1 over cosine squared, I don't know what 1 over cosine squared is, but you know what I do have is a 1 over cosine of theta rule. Anywhere? Yes. 1 over cosine of theta is equal to secant of theta. So therefore, 1 over cosine squared is secant squared of theta. And that's going to be another rule in my toolbox. Okay. So now I've got 4 rules. I can come up with 2 more rules. Let's say I rewrite this rule. 1 plus cotangent squared is equal to cosecant squared. One plus tangent squared is equal to 1 plus tangent squared is equal to secant squared. Right? Let me just double check from rule number 3. Oh, sorry, that was rule number 4. 1 plus tangent squared is equal to secant squared. Okay, well, how do I get, well, if I know what secant squared is there a way of figuring out what tangent squared of theta is? Just get tangent squared of theta isolated. Yeah, I'm going to subtract 1 from both sides. So now I've got tangent squared of theta isolated is equal to secant squared of theta minus 1. A new rule. It takes a little bit of flexibility. A new rule. So tangent squared of theta isolated is secant squared of theta minus 1. So we did that. 1 plus cotangent squared of theta is equal to cosecant squared. And that'll be the last rule I can come up with. Okay. So how do I get cotangent squared of theta isolated in this case? I'm going to subtract 1 from both sides. Now let's see what happens when I get cotangent squared isolated. Cotangent squared of theta is equal to cosecant squared of theta minus 1. And finally, we have our sixth corollary from the Pythagorean theorem of trigonometry. Now, I'm not expecting you guys to memorize all these, because what I've done is created all these rules that you need to have at your disposal for these trig proofs. We'll get to the positive negative arguments in a future video. So for now, know the trig ratios and the Pythagorean theorem manipulations. In other words, what rules can I conclude from the Pythagorean theorem of trigonometry? So I'm going to refer to this in the videos, because I don't have a printer at home, and plus it's color coordinated. I like it. I'm very happy about that. So without further ado, let's do these two proofs. Okay, let's start with number one. Sorry, I didn't complete proof number two, so let me get my book out really quick. I didn't put an equal sign on my problem. So, start copying. Secant of theta minus secant of theta sine squared is equal to cosine of theta. Sorry about that. Thank you for being patient. Sine. Okay. Sine. Okay, so these are both very similar proofs. Okay, so we want to show, using the list of rules in our document, that the left side is equal to the right side using the rules. Well, I noticed that I have a simple right, so I'm not going to use the left and right meet in the middle method. Instead, I'm just going to use the standard left proves right. So I'm stuck with secant of theta minus secant of theta sine squared of theta. Well, remember back in algebra where I can factor out the GCF. So secant of theta minus secant of theta sine squared of theta, I'm going to factor out secant of theta. So now, if I factor out secant of theta times what is secant of theta? Well, that would be 1. Secant of theta times what is negative secant of theta sine squared of theta? So as you can see, all I did was factor out secant of theta, and I'm left with secant of theta times the quantity of 1 minus sine squared of theta. Okay, now that I've done a good first step, let's see hey, wait a minute. I've seen 1 minus sine squared of theta before. What rule is 1 minus sine squared of theta? Cosine squared of theta. 1 minus sine squared of theta is equal, let me get my green, to cosine squared of theta. So now I've got secant of theta times cosine squared of theta. Okay, can I do anything else? Well, secant of theta is 1 over cosine of theta, right? From the trig ratios, secant is 1 over cosine. Okay, so I'm going to break that up. Cosine squared, well, that's just cosine of theta times cosine of theta. Or I could just jump it and say cosine of theta over 1 times cosine of theta over 1. And now I'm going to put it all together. I've got cosine of theta over cosine of theta. Can anything cancel out on the top and bottom? Yeah, 1 cosine on the top and 1 cosine on the bottom, and I'm left with cosine of theta, which is what I wanted all along. And that is a thorough proof. They're like little puzzles, aren't they? All right, let's do one more and then we'll call it a day. Very similar. So if we've got cosecant of theta minus cosecant of theta, cosine squared of theta is equal to sine of theta, how do I prove beyond a shadow of a doubt that the left side is equal to the right side? Well, just like the first problem, they both have a GCF, the greatest common factor of cosecant of theta. So I'm going to factor out cosecant of theta. Remember that cosecant of theta times 1 is cosecant of theta. Cosecant of theta times what is negative cosecant of theta cosine squared of theta? And all I did here was factor out cosecant of theta. So now that I've done that, cosecant of theta gets factored out. And now, hey, I see a Pythagorean theorem manipulation from 1 minus cosine squared of theta. Hey, 1 minus cosine squared of theta, where do I see you anywhere? Sine squared. So if 1 minus cosine squared of theta is sine squared of theta, now I'm in business. I've got cosecant of theta times sine squared of theta, and I know that I can rewrite cosecant of theta as 1 over sine of theta. And I can write sine squared of theta as sine times sine, or sine of theta over sine of theta. Sine of theta over 1, sorry about that, times sine of theta over 1. And now I'm going to multiply across sine of theta over sine of theta. And a pair of sine of thetas are going to cancel each other out, leaving me with sine of theta. And the left proves the right. All right, we're going to do more Pythagorean theorem manipulation proofs in the next video. Have a great day.